Hello friends, now today we will discuss about the differentiation. Differentiation is nothing about the rate of instantaneous change, time change. Now if we have rate of change, then we always go for the slope. Now if we have the graph, like this is your x-axis and this is your y-axis, right? So now if we have a slope, if this is a curve, and I am taking 2 points on x-axis, this is your x distance from the origin, and then another point on x will be h distance, so this point will be x plus h and this will be your x. Now same we know, like y is the function of fx, y is always the function of fx. So now this is the y-axis, the point on y-axis will be what? This is x, so this will be your fx, and this is your x plus h, so this will be your fx plus h. So now this point will be what? X comma y, and this point will be what? X comma y. So here the x is x and y is fx, and now for this point x is x plus h and y is fx plus h. Now we know how to find the slope. Now we find the slope of this line tangent. Now we find the slope of this tangent line. You know the formula for slope. Slope formula is y equal to y2 minus y1 upon x2 minus x1. Now here y2 is what? y2 is fx plus h. This is your x1 comma y1 and this is your x2 comma y2. So now y2 is what? y2 is fx plus h minus what is your y1? y1 is your fx minus fx upon what is your x2? x2 is x plus h minus what is your x1? x1 is your x. Now this is your x. Now we take the limits. Limit as tending to 0. Limit as tending to 0. fx plus h minus fx upon x plus h minus x. Here we can see we are having the plus x and minus x, so we can cancel it. X get cancelled. So limit as tending to 0, fx plus h minus fx upon h. Here the h is in denominator, so we do see limit as tending to 0, h is not equal to 0. Why h is not equal to 0? If h will be 0, then anything upon 0 is always give you the infinity and things will be not defined. Therefore we do write h is not equal to 0, and this is your average of fx. Means derivative is nothing but the slope of a tangent line. Now we'll do one example based on this. Now for finding the average of x, we want fx plus h and fx. Fx we do have, fx is x square, so fx plus h will be what? X plus h the whole square. But now this is we have of the form a plus b the whole square. What is a plus b the whole square? A square plus 2ab plus b square. So now we substitute this fx and this fx plus h in this. So what we will get? Average x equal to limit h tending to 0, fx plus h is this, x square plus 2hx plus h square minus fx. Fx is this minus x square upon h as it is. Again now we can see plus x square minus x square will get cancelled. Now what we do have is limit h tending to 0, 2hx plus h square upon h. Now can I put the limit? No. Why? Because h tending to 0. If I put h equal to 0, it will give me infinity. So now I will try to solve and simplify it. Limit h tending to 0. H is common in numerator. H is common, 2x plus h upon h. Now I can simply cancel this h. What I have got is limit h tending to 0, 2x plus h only. Now I can easily put the limit because there is no h in denominator. So therefore this will be equal to 2x plus 0, which is 2x, which is your f dash of x. Which is your f dash of x. Now I will give you another example in trigonometric function. Now in standard we know if function is fx equal to sin x, then f dash of x will be cos x. But now we prove it by using the first principle of derivative. So now what we want, fx is sin x. We do need f of x plus h, which will be sin x plus h. Now what is the formula? F dash of x will be equal to limit h tending to 0 fx plus h minus fx upon h. Now we will substitute these two in this, so we'll get limit h tending to 0 fx plus h is sin x plus h minus our fx is sin x upon h. Now sin x plus h minus sin x, we have learned the factorization formulas. There are 4 formulas. What we have is sin plus, I'll explain that a little bit. Sin x, if I have sin a plus sin b, then we do write 2 sin a plus b upon 2 cos a minus b upon 2. Now if we have sin a minus sin b, then we do write 2 cos a plus b upon 2 sin a minus b upon 2. If we have cos a plus cos b, then we do write 2 cos a plus b upon 2 cos a minus b upon 2. And if we have cos a minus cos b, then we write minus 2 sin a plus b upon 2 sin a minus b upon 2. So these are called factorization formulae. Now how to remember these formulas? Now if we have sin plus sin plus, then we say 2 sin cos, because the middle part, the angle will be same, a plus b upon 2 a minus b upon 2. If we have sin minus sin minus, then we do say 2 cos sin. If we have cos plus, then we do write 2 cos. And if we have cos minus, then we will write minus 2 sin. So this way you can remember these formulas. Okay. So now our case is sin minus. Which one is that? Second one, sin minus. So formula will be sin minus 2 cos sin, means 2 cos a plus b upon 2 sin a minus b upon 2. So now what we'll do, limit h tending to 0 sin minus 2 cos sin 2 cos. Here we do have a plus b upon 2. Here a is x plus h and b is x. So a plus b means x plus h is a plus b means x upon 2. 2 cos sin a minus b upon 2 sin, your a is again x plus h minus your x is b upon 2. This upon h. Now here again limit h tending to 0 2 cos. Now we have x plus x is 2x, so 2x plus h upon 2, and plus x minus x will get cancelled, sin h upon 2 upon h. Now I am doing it here. Now what we have, limit h tending to 0. Still now I can't put the limit because first I want to resolve this part from the denominator, because this is h. If I put the limit then it will give me infinity. So that's why limit h tending to 0. 2 cos 2x plus h upon 2. I'll separate the denominator. So what I'll get, 2 cos x plus h upon 2 and sin h by 2 upon h. Now again we have learned one thing. What is that? Some standard limits we do have. Now if we have like limit h tending to 0 sin x upon x, then this will give us 1. If the sine's angle is same and denominator is same, then the limit h tending to 0, limit x tending to 0 will be 1. Here we do have x angle, so x. So now similarly we have h upon 2 over here. Sin h upon 2, angle is h upon 2. If denominator may be having the h by 2, then we can easily say this part to be 1. So now what I can do is dividing by 2, multiplying by 2. So now I'll separate the limit. So limit h tending to 0, 2 cos x plus h upon 2 upon 2, and now this part is separate. Limit h tending to 0, sin h upon 2 upon h upon 2. So now this part will give us 1, and now here we do have 2 will get cancelled. Limit h tending to 0, limit h tending to 0, cos x plus h upon 2, and this will give us 1. Now what we have, now we can easily put the limit because we don't have any h in denominator. So therefore after subtracting the limit, cos x plus 0 upon 2, which is cos x, and which is your f dash of x, as we have learned from the standard, like if fx is sin x, then f dash of x will be cos x, and now we have proved the same by using the first principle of derivative. So similarly, if you have like fx equal to sin x, then f dash x will be equal to cos x. Now I'll tell you some of the standard differentiations for which again and again we don't have to use the first principle of derivative. So now here I'll add the fx, and here I'll do write the derivative. So now first of all, in derivative, the derivative of x will always be 1. Now if we have k, I mean constant, then derivative of constant will always be 0. If we have x is to n, then derivative of x is to n will be n x raised to n minus 1. If we have 1 upon x, then derivative will be minus 1 upon x square. Now if we have 1 upon root x, no, if we have root x, then derivative of root x will be 1 upon 2 root x. If we have log x, then derivative of log x will be 1 upon x. Similarly, we have the same for trigonometric functions, fx, f dash of x. Now, if function is sin x, just now we did sin x ka derivative will be cos x. Now, if function is cos x, derivative will be minus sin x. Similarly, we have for tan x ka derivative will be sec square x. Then we have cot x cot x का डेरिवेटिव will be minus cosec square x. If we do have sec x का डेरिवेटिव will be sec x tan x. And now if we have cosec x, then derivative will be minus cosec square x, cot x, minus cosec square x, cot x. So now these are the some standard functions and whose derivative are respectively. Now we'll do one more on the first principle, because we did before for the trigonometric functions. Now we'll do it for the algebraic function. But there are some rules also in differentiation we do have, like UV rule, U upon V rule and all. I'll explain that first. Now, if we have y equal to U plus V, this is called the sum rule. If y equal to U plus V, then simply y dash. Y dash simply means f dash of x. Okay, so y dash, which is f dash of x, will be U dash plus V dash. Now if we have difference like y equal to U minus V, then derivative will be y dash will be equal to U dash minus V dash. This was fine with addition and subtraction, but now we have something different. If y equal to UV, we called it as product rule. Then the derivative will be what? Y dash will be U derivative of V plus V derivative of U. This is called the product rule. And now if we do have y equal to U upon V, which is called quotient rule, then what we can do in this, y dash will be, now here we do have U and V dash, but now in this V, derivative of U minus U derivative of V upon V square. Now in the same way we have one more for the product, like if we have the three variables U, V and W, so in this derivative will be y dash will be equal to U dash V and W plus U V dash and W plus U V and W dash. Dash are all the respected differentiation with respect to x. These are some of the standard rules. Now if we have, for example, y equal to fx, which is x square plus 2x plus 1. Now we have to find the derivative of this y with respect to x. So what we'll do? So now we want y dash, means f dash of x. X square ka derivative will be what? We have learned, like if the function is of the type x is to n, derivative will be n x is to n minus 1. Now comparing this x square with x is to n, what will be n over here? N will be 2. N will be 2. So now comparing this the same, like we will get n is 2, x is 2, 2 minus 1, which is 2x, is to 1, which is 2x. So derivative of x square will be 2x plus. Again we have learned what, if the derivative function is x, then derivative will be 1. So here 2 is in constant, like multiplication, and x ka will be 1. Now here the 1 is complete constant because there is no variable with that, and we know that derivative of constant is 0. So here it will be 0. The final answer is 2x plus 2. Similarly we have for the subtraction also, if we have the minus sign, then we have to treat respectively. But now I will do one for UV and one for U upon V. If y equal to x square into log x. Now here we have the algebraic function and logarithmic function also. But now in this case, now we have to treat this as u and this is our v. But what is our formula of uv? Y equal to uv. Then we do say like y dash will be u derivative of v plus v derivative of u. So now here u is x square and v is log x. We know x square का derivative is 2x and log x का 1 upon x. So y dash will be u is x square multiplied by v dash means derivative of v. So log x का derivative is 1 upon x plus का plus. Now v is again log x. So only v is there. So don't write the derivative of that log x. Into now we have to write u dash. U का derivative x square derivative is x square का derivative is 2x. Now if here we can simplify further, then go for it. Now here it's x square and here it is x and both are dividing. So now one x will get cancelled. So we will get x plus. It's better you write the algebraic function first 2x log x. So this is the derivative of this function which is of the form uv. And yes, one more standard derivative is there which I have not told you about. Like if you have e raised to x exponential function, then derivative of exponential function is always same. E raised to x derivative will always be e raised to x. Now if we have y equal to, I do say like x upon sin x. Now this is of the form u upon v. So what is the derivative of quotient rule? Like if of the form u upon v, if y is u upon v, then we know y dash will be what? Y dash will be v derivative of u minus u derivative of v upon v square. So now here we treat again as same y dash equal to v is sin x. So we do write sin x multiply by u dash. U is x. So derivative of x is always 1 minus u is x. So now they are asking for u. So you just write u. Don't write the derivative. U is x. But now here we do have v dash and v is sin x, and sin x का derivative is cos x. Cos x upon v square means sin x the whole square, or you can write sin square x are same. So what we have, y dash equal to sin x into 1 is sin x minus x cos x upon sin square x. Now here if you can simplify further, then go for it. Now I do know like I can do further because first I am separating the denominator. So sin x upon sin square x minus x cos x upon sin square x. Now here I can see there are two signs and there is one. So one sign will get cancelled. So what I will get is y dash will be equal to 1 upon sin x minus x cos x upon. Now here I have two sign like sin square x I am having. I am just separating it sin x into sin x. Now what is 1 upon sin x? We do in trigonometric function 1 upon sin is what? Cosec. This is cosec x minus x into what is cos upon sin? Cos x upon sin x is cot x. Cot x. Then this is 1 upon sin. 1 upon sin is cosec x again. So what we have got finally is cosec x minus x cot x into cosec x. Again if you want, then we can take cosec x is in common. So cosec x is common, 1 minus x cot x. So this is our y dash. Even if you want, you can stop here, but if you are getting the further simplification, then you must go for it. So this was all about the quotient. Now if we have something of this type, if y equal to sin x upon cos x, and if they have asked you to find the derivative of this, means y dash, then you say this is of the form like u upon v. Now if you apply the quotient rule, like you have to do that v derivative of u minus u derivative of v upon v square. But before starting the solution to finding the any derivative, look at the question. If you can simplify it before only, then do that, then your like load will be lesser. So now I can see sin x upon cos x is given, but before doing the u upon v, I can go for sin x upon cos x is what? Tan x. So y equal to tan x. Now what is the derivative of tan x? So if I say y dash will be sec square x over, instead of applying the u upon v and getting the answer, it's better first to simplify the question itself. Now sin x upon cos x is tan x and derivative of tan x is sec square x. And now if we have y equal to e raised to x plus 2 sin x, then what will be the derivative? Now here we have one exponential function and one trigonometric function. If I add some more, like if I say 3 log x, so now what we'll do is y dash will be equal to e raised to x ka derivative will be e raised to x. Now here the 2 is constant but with the variable, so it will come out, and derivative of sin x is cos x, and then we do have 3 outside, derivative of log x is 1 upon x. So this way you have to proceed. Got it? So this was all about the differentiation I did today. Differentiation is nothing but instantaneous rate of change, and when the things come to rate of change, we always go for the slope of a tangent line. So what was the formula for if y equal to fx? If you want to find the derivative by using the first principle, then y dash means f dash of x will be equal to limit as tending to 0 fx plus h minus fx upon h. Here h is not equal to 0, and while solving the functions, first you try to resolve, like eliminate this h from the denominator so that you can substitute the limit. Otherwise if you will substitute before, like if you are having the h in denominator, then you will get answer as an infinity, which is not valid. So therefore try to cancel this h with the numerator somehow and then substitute the limit, and you will get the answer for the function. Got it? So this was all about the differentiation, and this is called first principle of derivative. If I do one example, like without using the any trigonometric functions and all, we have seen like if y equal to x square, then y dash is 2x. If I do this by first principle, so what I need first of all, like this is y is fx, right? Fx equal to x square. For first principle I want fx plus h, so fx plus h will be what? Fx plus h will be what? X plus h the whole square. Now what is my formula again? F dash of x will be equal to what? Limit h tending to 0 fx plus h minus fx upon h. Now limit h tending to 0. What is my fx plus h over here? This is x plus h. It's better I solve it here only, a plus b the whole square. So what it will be? X square plus 2hx plus h square, which is what? X square plus 2hx plus h square minus fx is x square upon h. This will get cancelled, h will be common, so h 2x plus h upon h, this will get cancelled. So 2x plus h, now we can put the limit because we don't have h in denominator, so limit I am putting, so I am getting 2x plus h, which is 0. So 2x is the answer. Fine. So